So just going to start going here. Hey everyone, welcome to nTop Live. My name is Gabrielle Phelan, and I'm on the application engineering team at nTopology. In today's session, I will be giving an overview of how you can really automate design tasks through nTop workflows. So I'm going to show off some of the capabilities of some of the already configured workflows within our toolkits here. And then I'm actually going to guide you through the steps necessary to configure your own workflows within nTop. So right now we're looking at the main nTop interface, and you'll notice to the top right corner here, we have 5 tabs here: the additive manufacturing, architect materials, design analysis, lightweighting, and topology optimization. So these are our toolkits, and within these toolkits, we really identified workflows that were commonly used by designers across various industries. So essentially, we built these workflows using the lower level blocks that exist within the tabs to the left of these toolkits. And what we did is we exposed inputs to various workflows, designated an output, and then packaged all of this information into a nice, easy to use block that enables designers to quickly start transforming their geometry. So for example, if we go into lightweighting, we have various blocks here already created, such as shell and gyroid. Or if we go into additive manufacturing, we have another block here that says perforate from CAD phase. And so you see these various inputs, and what we did is we just really took a lot of these lower level blocks, packaged them, and then created this nice simple block that you can immediately start using. So for example, if I input this CAD bracket here, let's select a face. Let's select this entire body here. And what I can do is start just dragging in these inputs and start designating values here to quickly start transforming my geometry. So shell and gyroid. See that I quickly did that with that block. And then maybe let's perforate a CAD face. So add some drain holes here. So all I need to do is drag in the body I want to apply this function to, a face that I want to perforate, and start inputting some more values here. Just like that, I'm able to apply that modeling operation to this geometry very quickly with these blocks here. Along with that, we also have, again, lightweighting. We have maybe a workflow already created for structural ribbing. So again, let's maybe import another geometry here. Let's do this nozzle. Clean up my notebook here. Again, just need to start filling out these inputs. So let's apply it to this CAD face. Let's add a rib height, a rib thickness. Once we're done doing that, I'm quickly able to apply some structural ribbing to this part. So we have these existing workflows, but what nTop platform enables you to do is create your own. So you can automate any sort of task within nTop. And a really cool example I want to show is, let's switch over to this instance of nTop, is this workflow that I created here, and it's a build estimator. So I said you can automate any sort of task within your organization, and that could be even a task that goes beyond just modeling. It could be, for example, a computational task. So what this workflow does is that it takes an input mesh of your geometry, and then based on various inputs by the user, it calculates the machine time cost, material cost, and total cost to build that input geometry. So this really isn't like a modeling workflow, it's just a computational one. And this is possible because nTop platform is a computational modeling software that has enormous power under the hood. So for example, within my input section of my notebook here, these are the inputs that I want to expose. So when I later package all of this information, you're going to see that I'm going to get a nice block where you can only see these inputs that the user will be able to enter in here. within the body section of my notebook, I have a lot of mathematical operations going on here. So the actual workflow, the computations that I want to perform. And then I have an output section of my notebook. So I want to output these values here, and I designate that as an output. And then what I'm going to do is by just simply saving this workflow, I can then import it into a different instance of nTop where it becomes a nice package searchable block. And it will now look like something like this. So you see that it's now this block. We have all my inputs that I exposed here, and I have different values that I entered. And right now we're just looking, I have an input mesh of this heat exchanger. And by dragging it into this section, I'm quickly able to output those values that I was looking for later. And again, this is now a task. So I did the work to create all these computations and stuff. And now it's something that I can just reuse on any sort of geometry. So for example, maybe this other geometry here. So by just dragging this input mesh out and dragging this one in, you'll see that it starts calculating. You're going to see all these blocks start to regenerate. And there we go. I'm quickly able to output those values. So I showed you some of the out-of-the-box workflows within nTop. We have a lot of like surface texturing. If you've been in nTop before, you've seen a lot of these, a lot of light weighting, so like shelling and filling, structural ribbing. And then I showed you how you can kind of create your own. So using the input section of your notebook, performing the workflow within the body of your notebook, and then designating output. And yeah, so the build estimator workflow that I showed you in today's session shows that we can create workflows that go beyond just modeling because it's, again, we're enabling you to use these really powerful computational algorithms that are the foundation of nTop platform. So before I open up to questions, I just wanted to remind everyone that this video is being recorded and it will be posted later on our YouTube site if you want to go back and reference it. And then, so yeah, let's open it up to questions now. Oh, okay. So someone asked, where do you see the outputs such as this time? You see the blocks, but you're not seeing the actual value. If you look at the top right corner of these blocks, you see these values here, kind of small to the right, but we can get our outputs there. Also, if you open up by selecting the question mark and going to the properties tab of that block, you can also extract the build time. So you see that value again. Okay, so someone asked, can I provide the examples as well? Yes, those will also be available. Let's jump in here. Again, I definitely suggest that you explore different of these existing workflows within nTop, such as like the surface texturing workflows within architected material. A lot of cool stuff there. I did a webinar showing a lot of those different surface texturing capabilities that you can also look at. Okay, someone asked, is there any way to extract as a CSV, so extract the outputs as a CSV to avoid manually extracting that info? This would be useful when one has many outputs. Yes, that's definitely a possibility with an nTop platform. What we could do is actually text. What we could do is we could really like extract those different values. So if you went within nTop platform, to go into those properties, again, we can we get all these values here, and basically we could extract those and export them in different ways, like through the concatenate text block. I also believe there is a way to completely export. There's a few different ways we can do that, but if you definitely want to see, or if you want to see an exact way we can use that concatenate text, please feel free to reach out to me, and I can share a file with you how to do that. Okay, so structural ribbing, can it go in the axial direction, like straight ribs, just circumference? So I mentioned how a lot of these workflows within the toolkits, they're pre-configured. So for example, let's go into lightweighting and let's grab that. So we see the structural ribbing here. So we have these inputs here. So this is an out of the box, like this will get you structural ribbing right away. But I also mentioned that the way that we were able to form these blocks was using a lot of these lower level blocks to build. So actually under the hood of this block, there's a series of blocks like conformal, lattice from CAD phase, and then we reparameterize and we start to build it, and we build this block from the ground up. The reason I'm mentioning that is that when you learn how to build these workflows from the ground up using these lower level blocks, you can have a lot more control. So being able to change the direction of that structural ribbing. So yeah, I definitely recommend the toolkits. The workflows within the toolkits are really helpful when getting workflows right away. But when you really start understanding what's going on under the hood of those toolkits, you can have a lot more control of your geometry. Any more questions for me before we wrap things up? Yeah. So if there's no more questions, I'll start wrapping things up. Just again, please make sure to continue attending these live sessions. Oh, 1 second. Someone has a question. But while we're waiting for that, yeah, please continue to keep on attending these sessions. We're going to be having them, I believe, every Monday, Wednesday, and Friday, and continue posting really cool applications with nTop platform. We're always coming out with something new. I always feel like I'm catching up with what we're able to do within nTop. So lots of cool stuff to come. All right, so question, how do you make gyroid infill patterns with various parameters? Okay, let's show something really quick. I think this is a cool file that'll show some gyroid manipulation. All right, so hopefully you're seeing my screen. And we're looking at that gyroid infill, and there's a couple different things going on here. So what I did, I filled a volume. In this case, it's just a simple box, and I filled it with a wall TPMS. So what you're going to do is we have this block called wall TPMS, and we can control the cell size, approximate thickness, and the bias length. And in this case, I'm manipulating the thickness using this modifier that I named wall thickness. So if you want to manipulate different parameters of your geometry, what you want to use is this ramp block. And in this case, I'm manipulating this wall thickness based off of a plane that I placed here. So the further I move away from this plane, you can see I'm increasing the thickness, and the closer I am to this plane, we have a thinner wall. So if you want to manipulate thickness, this ramp block or other values, for example, there's another thing going on here, such as the periodicity. So being able to change the periodicity. I believe I did an nTop live in which I showed a simple example of this, and also the pressure vessels. So if you want to get more into the details of how we use this remap field to vary like the periodicity of the structure, I recommend going back to that nTop live in which I go over what this remap field block is doing. Cool. Is it already possible to introduce a vector or image such as a logo on a surface or repeat among the surface? Yeah, so I think up from the top of my head, what you could do is you could bring that logo in as CAD. Once you convert it to an implicit body, which is that native geometry within nTop, there's a lot of mathematical functions in which, I mean, if you go into Math tab, we have a lot of cool stuff here. So what you would do is maybe use like a plane from normal, and then you could orient that plane along the surface using some vector math here, and then you could array that logo across the surface. So there's some different ways we could do that within nTop. But, all right, so I think if we don't have any more questions, I'm going to wrap things up. And thanks for joining, and yeah, thank you for your time.